Aloha, Rich Alverson here. This is ITS388AL, and today I'm going to go over the first assignment where you need to convert the MIPS simulator written in C. You have to convert that into Python. So let me share my screen. And so I'm talking about, the assignment is go to 5 point, or go to the C simulator um, section in the textbook, and here we have a C version of this MIPS simulator, and you can see that there are four instructions here that it executes. It executes an add immediate, which essentially loads a register. It loads a word from memory where the address is specified in that register, and then it doubles that value and stores it back out again. So and when we execute this program in this C simulator here in the textbook, we see this is the instruction register, and these are the registers after the execution of the first instruction. It's the memory, and after the second, third, and fourth. And so what we're supposed to do in this first assignment is to convert this program into a Python program. So I'm going to first start by copying this out. Control A, Control C, and I've got a Python program here. In fact, let me just verify this. I'm going to do print hello there, ITS388AL, and I'm going to save this, and I'm going to pull up my command prompt here, and I'm going to do Python. See, what did I name it? Python. I think I've got Python 3 installed. MIPSzy. It says, hello there, 388AL. Okay, great. So I'm going to paste in this program now that I just copied from the textbook here. But this is a C program, and we have to convert this into Python. Okay, so let me first I can get rid of this. Well, let's see, maybe I'll leave that there. Okay, so the first let's look and see what this program does. Okay, so first of all, this is the main program here, and this is in C. And we first of all we initialize some of the variables that we're going to use. We have to do that in C. And this is another character variable, and this variable is actually used for converting the binary number into a string, which we can write out. And then here's four instructions. Okay, and this is an add immediate 5,000 plus 0, and store that in temporary register T6. And then we're going to load into temporary register T0. We're going to load the value at the data memory address that is stored in T6. And we stored 5,000 in T6. So this instruction is going to go out to memory location 5,000 and grab that value and store it in T0. Okay, that's what that instruction does. This instruction here takes the value that's in T0, which we just grabbed out from memory location 5,000, takes that, we add it to itself, both T0, and we store the result of that value into register T1. And then we store out what's in register T1, we store that back out into the address, the memory location, whose address is defined in T6, which is up here. Okay, so it's a very simple program. And when we execute that program, we see that over here, we see that this is the instruction. After the first register T, turns out that T0 through to T7, that maps to RF8 through RF15. So this is, turns out that this is T0, T1, T2, T3, T4, T5, T6. That's just something we checked about MIPS. And in another video, I'll talk about how we go to Wikipedia, look at the MIPS instruction set and all that, because we're going to need that for the future assignments. All right, so that's the first instruction loads the value 5,000, which is going to be a memory address, into T6, and then it sticks. Uh, uh, this is just some random value that we're going to put. This is memory location 5,000, turns out, and then we go and grab what's out of memory location 5,000, which maps to this location having to do with where the instruction memory is and where the data memory is, and we talk about that in another video. So we grab that out, we store it in register T0. This is T0, and then we're going to take this and we're going to double it to store it in T1. So here I will take it and we double it in T1. And then we take this 44, the next instruction, take the 44, and store it back out into memory location 5,000. So instead of 22, it's going to be 44. All right, so that's what this, when we execute this program, these 4 instructions in instruction memory, this is how the memory and register file are affected. Okay, so and the assignment here is to convert this C program to a Python program that we can execute. Okay, so let's, it turns out that there's a lot of stuff that we don't need in the C program, and we're just going to change a little bit of the syntax and so on, and it'll end up working in Python. So first of all, this has to do with the bringing in standard I/O in C, and we don't need that, and the hashtag indicates a comment in Python, so we're just going to leave that there. And then it turns out that we aren't going to need any of this, because this is something that converts a binary number into a string that we can write out, and we can take care of that very easily in Python. So I'm going to make this whole section here a comment by closing it in triple single quotes. Okay, now we have this is a function that prints out the register file. This function here goes from 0 to 16. That's what prints out all the register file right here. Okay, all that. Okay. Okay, and so that's what that does. So let's fix this. Let's change this to a def, because it's in Python we define our variables with a def. The name is fine. We don't need this garbage. Python takes care of that, and we don't need the fact that it's an array. It just knows it's an array or a list. Okay, now we don't need this curly brace. We're going to leave the indentation just as is. Okay, so don't mess with the indentation, because in C it doesn't affect anything. We can mess with the indentation, doesn't matter. But in Python it absolutely matters, and that's because we don't need these curly braces. So we don't need a curly brace, but we do need a colon. So we're going to just place that curly brace with a colon. Then we have a for loop, and this loops through from 0 to 16. So for I equals in the range of 16. Place the range of 16. Let's replace this with a colon. So this is going to loop. Now the print is going to be, let's see, let's do the closest to a Python print. I'm going to take off the F. We're going to leave that there. %D is fine. Colon. I'm just going to make this a D also, because I'm not going to. And I'm going to make this a %. Yeah, these two things in. Okay, so this is going to print the integer I right there as a decimal number. And this is going to print whatever this is, and this is going to be the register, the value in register file, whatever I is from 0 to 16. Okay, so, and let's see, Python doesn't care if you put it, you don't need a semicolon there, but Python doesn't care if you put one there. And we don't need this anymore, and we don't need this anymore. Okay, so that takes care of our writing the register file. Let's do this writes out the memory locations, and what it does is it looks in all the memory locations that are not 0, it prints them out. If they're 0, it doesn't print them. So let's change this to def, and let's get rid of this, and and it's going to be div is going to be a list or array. Let's make this a colon, and this is going to be for I in range of 1024, 0 to 1023, colon. If that's okay, let's make this a colon. If that's fine, if the ith index of the data memory is not equal to 0, then print out this. Let's make this also a D, I think. It's as a decimal number, and we do it this way, where we do a percent parentheses. So print the I here, and this value prints after that. All right, and we don't need this trailing this, or the trailing this, or the trailing this, because in Python it's taken care of with a colon here and then indentation, colon here, indentation, colon here, indentation. All right, so that's good. Instead of this int main void thing here, let's do a let's put one of these. Put that in there. Now I'm going to make this just a comment here, so we know where we are at. So I'm going to do this main thing, and I don't need this. I do need to declare my lists. So in Python we call them lists, and in C we call them arrays. So this array, and this array, and this array. And we can declare the existence of the array and make all the values 0. Like that's what we do here. We make all these array values 0. We can do that all in one fell swoop up here. So I'm going to do that. I'm going to say the register file is equal to an array containing 0, 16 of them. And let me comment out the rest of this here. Okay. So this declares my register file. Oh, and then this here I'm going to declare these two. Let me just tab this out a little bit. And I'm going to do I am and dm equals the IM is going to be an array all containing 0, 1024 of them, and dm is also going to be an array containing zeros, 1024 of them. Okay, so that's the same as this. It's the size of the integer arrays, unsigned integer arrays, 1024 of them. And there's this funny kind of addressing here because they want to separate the instruction memory from the data memory. But back in the old days, in the very beginning, a von Neumann machine, that was sort of the unique, cool thing about a von Neumann machine, and that is the data memory is the same as the instruction memory. So in fact, data memory, data memory is can be instruction. A data memory for one program can be an instruction memory. It can be instruction memory for another program. And in fact, that's what an assembler, a compiler, an assembler, and a loader. A compiler reads in your program written in text and converts it into its data is the machine code, which are these things, and those those codes turn around and and are in fact the program for the program that you're writing. Anyway, um, so so let's keep moving here. These can be all these are all comments. So I'm gonna comment these all out because we don't need any. We don't need to declare any of these. Okay, and in C a comment is slash slash, but in Python, it's a hashtag. So it turns out that these are all fine. Those declarations are all fine, but we got to make these comments be Python comments. We're assigning, these are the program instruction words, the ones and zeros, the instructions that are loaded into instruction memory. And then this is the, let's see, we need, let's see, comment, we do want to set the program counter equal to 0, but after that, we don't need any of this other stuff. In fact, I'm going to do this. I'm going to do dot, 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 and that makes this a comment all the way down to here. I guess I don't. Hashtag, 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 and then we want this. Now, in Python, this is going to be an integer. This is an integer divide. We want this because this is an index. This is a memory index, array index, or list index. It's got to be an integer. So this needs to be an integer divide. So all of these single slashes need to be double slashes. So let's make that a double slash. Make this a comment. Make this a double slash. This is an integer. Uh, make it put a colon here, and then make the rest of that comment. This could be a double slash, and this is a comment. We don't need this anymore. So we're just going to print it out. How are we going to print it out? I did it a couple different ways. Let me see. This other way that I do it. Well, fancy. Okay. See, let me just do. Let me just get rid of this here and make it be bin parentheses. Use the bin function of IR. So we print out. We use this bin function that takes this number and converts it into a binary number string. Comment this out. That's fine. I think all of these are fine. This is make this a colon. I'll do colon comment. Colon comment. 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 All right. This is fine, I think. This is, oh, this is going to be a double slash. I'll put a comment there. Um, This is a double slash. This is an and, a logical and in Python. I think we don't need any of these ending curlies. We don't have curlies in Python. This is in Python, it's ELIF. So let's get rid of that. ELIF, ELIF, ELIF. Let's see. How does this look? I don't need this is going to call print out the registry file. This is going to print out the memory. I do want to put a space in between them. Let's just do this. I'll put a space in between. And don't need this. Don't need this. Don't need this. All right. Well, I'm sure I didn't get everything, but let's save it and see what it looks like. All right, now it should actually run the program. Let's see. Go up one. Line 56. Okay, it's line 56, of course, is that's got to make that a comment. Okay, save it. What's next? It doesn't like printf on line 61. Okay, of course, it's just let's save this and run it again. Whoa, got down to line 59, 95 into this. It doesn't like this. Oh, there's a printf in there on line 25. Okay, so let's go to line 25. Oh, that you probably saw that. Okay, let's try one more time. And my gosh, it looks right. Okay, well, I think you can confirm that this is correct. And hope this helps. Thanks for watching.